Hi there and welcome to Penguin Learning. In this National 4 Maths lesson, we're going to continue doing practice questions for the National 4 Maths exam, but this time we're going to have a look at questions that involve us using a calculator. This means now that the sums that we want to calculate in order to solve problems or get a final answer would be a little bit too tricky to just do by ourselves or without using a calculator, so the calculator is going to give us practice using more complex sums. In this lesson we'll go over 4 questions, and what I recommend you do is try the questions first by yourself after I've laid out the question for you, and then afterwards you can follow along and check if you got the right answer. So let's get started.
Ooh la la!
Okay, so let's have a look at question 1. We are told that a ladder is placed against a wall to reach a ledge as shown in the diagram below. So we assume here that this is the ladder, here we have the wall, and the ladder rests at this point on the ground. And the point in this question is that we have to figure out the size of the angle marked x degrees, so this angle right here. So in a question like this, which involves an element of problem solving, we have to think back to everything that we have learned during the National 4 Maths curriculum and think, what tools did we learn to solve a problem like this, where we've been asked to calculate an angle and we've been given lengths right here for the ladder. So this is the height of the ladder up against the wall, and this is the distance it separates it against the wall. And the key thing to recognise is that this pattern right here forms a right angled triangle. And the 2 things that we've learned in order to solve something in a right angled triangle has been number 1, Pythagoras, and number 2, the trig ratios. But we know that Pythagoras is only used to solve another side when we have the other 2 lengths of a right angled triangle, but we can use trig ratios in order to solve an angle if we have the known sides of a right angled triangle. So it's going to be trig ratios that we'll use to solve this problem. And the very first step that we do when we go to solve a problem using trig ratios is to label each side of the right angled triangle. So to begin, we know that the side opposite the right angle is always the biggest side, and that's called the hypotenuse, so I'm just going to write HYP for short. And then we know that the side opposite the known angle, so x degrees, is called the opposite. And then the last side, the side that's adjacent or next to both the right angle and the known angle, as I said, is called the adjacent. So that means that we've labelled each side now. Next up, we have to figure out which of the trig ratios we want to use, and this is between SO, Ca and TOA. And to do this, what we have to figure out is what 2 sides we want to deal with out of the 3 possible sides of the right angled triangle. Well, we know that this side here is a known, so that's the 0.7 metres of the adjacent, and also the 2 metres for the opposite. We don't have any information on the hypotenuse, so that can be neglected. So that means we have the opposite and the adjacent, so that would be the OA part of the trig ratios, which tells us that we have to use the TOA trig ratio. And if we write this out, that's going to be the tan of the angle, so that would be the tan of x degrees is equal to the opposite over the adjacent. And if we put in the values for the opposite and the opposite is 2 metres, the adjacent is 0.7 metres, and if we put that in our calculator, that roughly gives us an answer of 2.86. You can either put it in this form or you can keep it in the fraction form. If you keep it in the fraction form, you'll get a more accurate answer at the end, but it doesn't really matter. So that means that we have the tan of x degrees is equal to 2.86. Now, because we want x degrees by itself, that means that we have to do something with this tan, and what we want to do is take it over to the other side. But in order to do that, what we have to do is take the inverse function of the tan, because we know that if we ever take the sine, cos or tan function over to the other side, we have to take the inverse of it. So that would look something like this. We would have x degrees is equal to the inverse tan function, so it's written like that, so we have the tan to the power of -1 always, and that is of 2.86. And then finally, if we enter this into our calculator, we should get an answer of approximately 70.7 degrees. So that's going to be the angle that the ladder makes from the wall. So again, the key thing for this question is to first of all identify that we have a right angled triangle and then take it step by step at a time. So label the sides, pick the correct ratio, put the values in, and then know what to do in order to isolate x by itself by taking the inverse tan function of the right hand side. Okay, let's look at question 2 now. We are told that the end of a ridged tent forms an isosceles triangle and is shaded below. So we can see here it's almost like a prism shape, and this is meant to be the end of the ridged tent, and this is the shaded surface. So we can see here we have an isosceles triangle, which just means that we have two sides that are equal and two angles that are also equal. And we're told that the base of the triangle is 160, so this is the base right here, and the sloping height is 200, so that's going to be this length right here, and we're asked to calculate the vertical height of the tent. Now we know that vertical means up and down, so what the question is asking us is the height from the bottom part, so the base, up until the tip right here, and that's different from the sloping line because that's not a vertical distance and it's also not perpendicular with the base. So it's asking us essentially the height from here up to here. Now again, just like the last question, we have to use our problem solving knowledge and think back, what do we know or what have we learned to solve a problem like this? Well, first of all, we have to think what we have. So we have the vertical line that runs up and down, and that's what we want to calculate. And we can see here what that does is divide this isosceles triangle into two equal right angled triangles. So that means that this angle right here is going to be a right angle, and so is that angle right there. And what we can then also say is, because the base is a total of 160 centimetres, that means that from here to here it's going to be half of that, and that's also going to be half, and half of 160 is 80 centimetres. So that means that we can form a right angled triangle where we know two sides and we want to figure out the third side. So let's draw that out real quick to see what that looks like. So here we have half of the base, which was 80 centimetres, we have the sloping height, which was 200, and then we have the vertical height, which we want to figure out, and I've just labelled that as V. And we can see that because we have a right angled triangle, we have two known sides and one unknown side. That means that we can use Pythagoras in order to solve this problem. So first of all, what I'm going to do is label the sides A, B and C to fit into Pythagoras' theorem. So the hypotenuse is always A, and the two other sides are B and C. So to write out Pythagoras' theorem, it says that for any right angled triangle, A squared is equal to B squared plus C squared. A is 200, so that means we're going to have 200 squared is equal to V squared plus 80 squared. And then now what I'm going to do is just move the V squared over to the other side. So we have V squared, and then now what we want to do is take this 80 squared over to the other side, so we have V squared by itself and then the both number quantities on the other side. So because this is plus on that side, when we move over it's going to become minus, so that means we're going to have 200 squared minus the 80 squared. And then if we do this in our calculator, 200 squared is equal to 40,000 and 80 squared is equal to 6,400. And then if we take both of these values away from each other, we will be left with 33,600. And then to get V, what we have to then do is take the square root of that quantity, so the square root of 33,600. And again, if we put this into our calculators, this should give us an answer of approximately 183.3, and that's in centimetres. So that means that the vertical height for the tent is equal to approximately 183.3 centimetres. And again, the key thing is being able to identify, first of all, that we can divide the isosceles triangle into a right angled triangle, and then use our knowledge on Pythagoras to solve the problem. Okay, so now let's have a look at question 3. We are told that a work surface is made from a semicircle and a rectangle as shown below, and we're asked to calculate the area of the work surface. So here we have the work surface that was mentioned, and we can see that is made up of a semicircle here at the top and a rectangle here as well. Now the clue is sort of in the question by mentioning that the shape is made up of a semicircle and a rectangle by the fact that the way to calculate the total area is to maybe first calculate the area of the rectangle and then calculate the area of the semicircle, and then once we've done that we can add both of them together to get the total area. So what I'm going to do is just name the rectangle of the shape just 1 and the semicircle I'm just going to call that 2. So what I'm going to calculate first of all is the area of shape 1 or the area of the rectangle, and we know that the area of the rectangle is simply the width multiplied by the height. So I'm just going to write W for width and H for height, and that would be the 40 centimeters multiplied by the 70 centimeters, and if we put this into our calculators that's going to give us an answer of 2,800. And remember, the units for area is always the length squared, and in this case because we're using centimeters the units is going to be centimeters squared. So that's the area of our rectangle. Okay, so now what we have to do is calculate the area of our semicircle, which I'm just going to call A2. Now to calculate the area of a semicircle, what we can do first of all is calculate what the area of the full circle would be and then just simply divide that by 2. So how do we calculate the area of a circle again? Well, the formula for any circle is equal to the area is equal to pi, so 3.14, multiplied by the radius squared. So A is equal to pi r squared. And remember, the radius is just half of the diameter. So if that was the formula for a full circle, what we can say for our shape A2, which is a semicircle, would just simply be the same, so pi times the radius squared, and then all we have to do is divide the whole thing by 2, and that will give us the formula for a semicircle. So what do we need to know from this equation in order to calculate A2? Well, we have to figure out what the radius is. Well, what we can do, first of all, we can realise that this length down here is 40 centimeters, and because this shape was a rectangle, that means that this length up here is also going to be 40 centimeters. So that means we can see that that also means that the diameter of our semicircle is equal to 40 centimeters, and because the radius is half of the diameter, then we can just simply say that the radius is equal to 40 divided by 2, which is also just equal to 20 centimeters. So now we have everything we need to put into the equation. We can say that A2 is equal to pi multiplied by 20 squared, all divided by 2. And if we put this into our calculators, what we should get is an answer of around 200 pi, so 200 times pi. And to put this into our calculator, what we should get is an answer that is around 628.32, and remember the units is centimeters squared. So now we know both the area of A1, so the rectangle, which was 2,800 centimeters squared, and we know now the area of the semicircle, which was 628.32 centimeters squared. To get the total area, all we have to do is add A1 and A2 together, and doing so into our calculator, we should get an answer of around 3428.32 centimeters squared. So again, just to recap, what we did was first of all calculate the area of the rectangle, calculate the area of the semicircle, add both of them together, and that gave us the total area for this shape. Okay, so the fourth and final question for this lesson, we are told that Anna takes a train from Glasgow to Helensburgh, and the distance of the total journey is 23 miles, and it took the train 50 minutes, and we've been asked to calculate the average speed of the train in miles per hour. So straight away from looking at the question, we can recognise that this is a speed, distance, time problem, because we are asked to calculate the average speed, and we're given a distance which is 23 miles, and we're also given a time of 50 minutes. So this is how we draw the triangle with B on top and S and T on the bottom, Again, a way you can memorise this is just think that it's in alphabetical order. So D is first in the alphabet, then S, and then T. But for this question, we want to calculate the average speed. So what we can do then is cover this up, so I've highlighted it here, and the remaining other two values is what the equation should look like. So we can see that D sits on top of T, so that would mean that our equation is speed is equal to distance divided by time. Now the key thing with speed, distance, time problems is we have to consider units, and what we want our units to be in is miles per hour. So what that means is our distance should be in miles and our time should be in hours. So we can see here already our distance is already in miles, so that's okay. So we can see that D is equal to 23 miles, but our time is currently in minutes, but we want it in hours. So if we have a time of 50 minutes, how do we convert that into hours? Well, we know that 60 minutes makes up an hour, so in order to convert from minutes to hours, we want to divide the minutes by 60, and that will give us the value. So if you're doing a calculator, 50 divided by 60, we're going to approximately get 0.83 hours. So that means now that our distance and our time is in the correct units for the speed to be in miles per hour. So let's put these values into our equation. We have D is equal to 23 and the time is equal to 0.83, and put this into our calculator and we should get an answer of around 27.6 miles per hour. So again, with speed, distance, time problems, first of all we want to figure out what we want to calculate. So the speed, we draw the triangle and then we can get the equation from the triangle. So we see D sits on top of T, so that means we have the distance divided by the time, and then we consider our units. So we want miles, which was fine, we had 23 miles, but then we had hours for the time, so we had to convert 50 minutes into hours, and then we got our final answer of 27.6 miles per hour. So I hope this first lesson on calculator practice questions for the National Full Maths exam has been helpful to you. And if that's been the case, be sure to give the video a thumbs up. But if you have any problems on the 4 questions that we did today, drop a comment down below and I'll get back to you as soon as possible. And if you'd like to see more content like this, be sure to subscribe to our channel or head over to our website at penguin-learning.com. Thanks again for watching, and I'll see you in the next video.